So we have started streaming and started recording. So we'll get to the discussion for today. All of you seen week 7? Contents of week 7?
Yes, sir.
Okay, let me ask this way. How many of you have seen week 7? Okay, I have 2 thumbs up. All right. Okay, good. So today's discussion is going to be on the content of week 7. What is talking about in week 7? What is the focus of week 7?
Logistic regression.
So it is a logistic. Okay. So in logistic regression, the focus is basically going to be on a classification problem. So this is going to look at a classification problem. Okay. And let us, for example, see a binary classification problem. All right. This is the data that you have. I'm going to show you a data. And we are not going to look at building a logistic regression. That I will leave it to you to self-learn. What I will be looking at is, based on the result, how do you check whether your model is good or bad? All right, so that is going to be your focus. So I have observations. Let's say I'm having student observations. Yes 1, yes 2, yes 3, yes 4, yes 5, yes 6, yes 7. Yes 8, yes 9, and yes 10. So I have 10 students data. Okay, so that is going to be my data set. And what I'm trying to do is, I'm going to try to predict based on some parameters whether the student is going to pass BA or not. All right. So the actual result and my predicted result. So actually whether the student is passing the BA course or not. All right. So since this is a test data set, what we will do is we'll take the first 5 students pass. All right. And then the next 5 students are going to fail. Right. So that is the data set that we have. We had 10 students in the BA course based on some parameters. Let's say they're quiz 1, quiz 2, assignment 1, assignment 2, assignment 3, so on and so forth. We are predicting whether they will pass the course or not. And we want to predict, and this is our training data set. So we have 5 data points in the training data set, which is pass, 5 data points in the training data set, which is fail. Okay. What kind of a technique is logistic regression? In regression, logistic regression, all of these come under a branch of techniques in machine learning. Do you know what it's called?
Supervised learning.
It is a supervised learning, which means I need a data set where I have an observation and what is the actual value for that observation. Only then can I build the model and later on use it for predicting a new value that comes in. So this is a supervised learning. So we have this data set. Secondly, if looking at this data set, what can you tell about it? What kind of a data set is this? That is another feature that you usually look in for a data that is presented to you. What kind of data set?
Categorical.
That is okay. Categorical classification problem, that is okay. But what kind of a data set is this? Binary, okay, binary classification. We are going to look at a classification problem which is binary, okay. Even more basic, even before that.
Symmetric.
Symmetric, what is the other word for symmetric? You don't use the word symmetric in data set, but you use what? Why do you call it symmetric?
Because the number of actual in P and F is similar is of same numbers.
So when I have equal number of positive classes and equal number of fail classes, what is it called?
Balanced.
It's a balanced data set. So if this is a balanced data set. So we are looking at a regression we are looking at a supervised learning technique where the data set is balanced. Most of the time you will not have a balanced data set. Then also it's fine, it will most probably work, but balanced data set is always better. So just for the sake of completeness, I'm telling all of this. This is not a focus for this lecture, but just to give you a refresher, this is a supervised learning method in which we are taking a data set which is balanced. All right. So now let's say we have built the model. We have all of those x's with us. Using those x's, we have built the model and we have predicted. All right. So what I'm going to do is, for every 3 passes I predict, I'm going to have a fail. So what I'm basically writing is, I'm going to write pass, 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 fail. Then another 3 pass, and then fail, and then 1 pass and 1 fail. Okay, this is what I have predicted. Fine. My logistic regression model, after building it for the data set, it has predicted these values for these 10 students. Okay. Everyone with me so far? Any questions? No questions? Super.
No.
All right.
No, sir.
Okay, wonderful. Now we are going to look at how to evaluate this performance of a logistic model, right? For which you will have a confusion matrix. So this is called the confusion matrix. Fine. There are different ways of drawing this matrix. I'm going to teach you a few, let's say, shortcuts for some of the formulas. So I'm going to use this structure, and this is the structure that I generally use. What I do is I always take the actual on my horizontal value and my predicted on the vertical column. Okay. So this is how I will be drawing my confusion table. The actuals will be on the let's say on the y-axis, and predicted will be on the x-axis, if you want to put it that way. Actuals are going to be horizontals, predicted are going to be verticals. And what are the two actual values that are possible? It is either possible, I can either get a pass or a fail. All right, let's say pass is equal to 1 and fail is equal to 0, for example. So we are going to have a class 1 and class 0 in the actual column, and a class 1 and class 0 in the predicted column. This is how I will always draw my table. I will put 1, 0, 1, 0. All right. Everyone with me so far? This is going to be a 2 by 2 matrix in which my actuals are going to be on the horizontal rows, and the predicted are going to be on the vertical columns, 1 and 0. When the actual value is 1 and the predicted value is also 1, what is this box called? What are the values that sit here called?
True positive.
Right prediction.
Correct prediction. That is not the word. It's true positive.
Positive.
So someone said no. So this is a true positive. So when the actual is also 1, the predicted is also 1, it is a true positive. When the actual is 0 and the predicted is 0, what is it?
False negative.
False negative.
True negative.
True
It's a true
negative.
negative. Because the actual is also 0 and the prediction is also 0. So it is a true negative. Okay. Now comes the tricky part. What is this? What is this box?
Which one are you pointing to?
I am asking for actual is 1 and prediction is 0.
False negative.
False positive. Sorry,
False
false negative.
negative.
False negative. False negative. Correct.
False negative. So this is a false negative. Why is it a false negative? Because it is falsely telling it is a 0 plus and the actual is 1. So the false and true comes based on the actual value, and the positive and negative comes from the predicted value. So when my prediction is different from my actual, it is a false, and when it is a 0, it is negative. Right? So false, negative. Then what is this? Then what is actual 0 and prediction 1?
False positive.
It is a false
False positive.
positive. All right. Very good. I'm deliberately writing this in this color because I'll show what happens later on. This is a true negative. Okay. So this is the cell. Now let's see for this particular problem. If I have to write, let us call this what is this color? Maroon, no? Why pink? So when I'm using pink as my classification, what is this value? When it is a positive, it is a positive. What is it?
True
From this
positive.
table, this is a true positive. This is also a true positive.
Sir, which one?
The first value, for student 1, the actual value is positive. The predicted
Yes.
value is also pass. So it is going to be true positive. For student 2, the actual value is pass. The prediction value is also pass. So it's a true positive. For student 3, the actual is pass. The predicted value is also pass. So it is a true positive. What is this? For student 4, the actual is pass. Predicted value is fail.
False negative.
It is a false negative. Exactly. So what is the next one?
True positive.
This is a true positive. What is this?
False positive.
For student number 6, it is false positive. All right. Then for the second one, student number 7,
False positive.
again false positive. Student number 8,
False negative.
True negative.
Sorry, true negative.
it's a true negative. So both he is failing and I'm also predicting it's as a fail. It is true negative. What is student number 9?
False positive.
False
It's a false
positive.
positive. What is student number 10?
True negative.
True negative. Super. Now, based on
What
my
is the name of
predictions,
this column?
which column? I'm just calling it pink. I'm
Okay.
just calling it pink because I want to fill in these values with pink.
Okay,
Next,
sir.
I will use green. So I'll call it green. It is just a way to get what value is. That is all. Let's go specific name.
Sir, this is square you have made. This is called confusion matrix.
Pardon me?
Sir, will you please repeat S6 and S7?
S6 is a false positive because he has actually failed, but we are telling he will pass. He has actually failed,
Yes.
but we are telling he will pass. So it
True and
sits,
false is, sir, true and false is coming out on the levels of predicted values.
yes, on the levels of the predicted value.
Yeah.
No, sorry. True and false comes from the levels of the actual value.
Sir, then
If the actual and the predicted are different, then it is
Yeah.
called a false. If the actual and the predicted are same, it is a true. The positive and negative comes from the predicted value.
And so the square box is confusion matrix, no?
Now the square box is the confusion matrix. That is why I've written it.
Okay.
Confusion matrix.
so, sir, why can't S6 and S7 are not false negative?
They are not false negative because I am predicting it as positive. No,
Yeah, but actually it is
Actually,
false.
it is
So
false.
it should be negative, no?
no. The positive or negative comes from the predicted value.
Okay.
My prediction is 1, so it is false positive.
Okay.
Look, in a confusion table, there are 3 terms. There is a true, there are 4 terms. There is a true, there is a false, there is a positive, there is a negative.
Negative. Yes.
The true and false, these true and false is going to be differing based on true if actual is equal to predicted. False if actual not equal to predicted.
Okay.
Positive if predicted is equal to 1. Negative if predicted is equal to 0. That is all.
Thank you, sir. Thank you. Thank you.
These are the 2 terms.
Okay. Thank you.
All right. Wonderful. So now we have got this. Now using this, we can put numbers into this matrix. So how many true positives do I have? 1, 2, 3, 4. There are 4 true positives for me. How many false negatives do I have? 1, only 1. How many false positives do I have? 1, 2, 3. And how many true negatives do I have? 1, 2. Okay. So my data set had 5 actuals. So 4 plus 1, 4 plus 1 equals 5. My data has 5 zeros, so 3 plus 2, that is equal to 5. Total data set size, 5 plus 5, that is 10. All right. Everyone with me so far? Any questions on this?
No, sir.
Wonderful. Now comes the interesting piece. I have built a model. How good is this model? All right. For this, we have three terms. We have accuracy. What are the other two?
Precision and recall.
Precision.
Precision and
Recoil.
we have three things. So what does accuracy tell me? I want it in words, don't tell me the formula. A lot of you would have memorized the formula. I want to know what is the meaning of accuracy.
The fraction
The
of
number
correct
of times
predictions out of
we-
the actual data.
Okay.
Positive plus true
Someone else?
negative divided by total.
I specifically said, do not tell me the formula, tell me the meaning, interpretation.
Okay, so sir, according to the meaning probably is key. The accuracy will tell us key whenever we have the same number of actual and predicted values.
Same number of actual and prediction values. That is not
It's
right.
a ratio of how many times I get it right.
That is all. So accuracy is basically going to tell me the proportion of correct predictions. Right? So that is basically accuracy in a nutshell. Of the total number of predictions that I have made, how many are correct? So if that is the case, what is the formula? Now tell me the formula. What is the formula for accuracy?
True positive
True
plus
negative plus
negative
positive
divided by total.
over total.
So that is accuracy. Of all the samples that I had, how many I have correctly predicted? Why am I interested in correctly predicted? Because why am I interested in TB and TL? Because both of them are correct. I have predicted that 4 people will pass the course, and for those 4 people have passed the course. I have predicted that 2 people will fail the course, and those 2 people have failed the course. Whoever I've done. So out of the 10 data points, 6 data points I have correctly predicted. That is accuracy. All right. Now tell me the formula for precision. Tell me the formula for precision, then tell me the interpretation. What is the formula for precision?
So 1 minute, sir. Sir, in that formula, we can write that TP plus TN upon all the number of data points.
Oh, that is what I've done. TP plus TL plus FP plus FN is total number of data points. That is why I showed you here. No? 4 plus 5, 3 plus 2, 5, 5 plus 5, 10.
Yeah.
Same thing. Because your entire data set is going to fall into one of these 4 boxes.
Yes.
So I'm just writing it like this.
Okay.
Yeah. All right. So that is accuracy. Now tell me the formula for precision, then tell me the interpretation.
True
That may be
positive
easier.
upon true positive plus false positive.
Wonderful. Okay. Yeah. Kalpita, I believe you have solved the practice problem. You are absolutely right. Whenever I tell you to tell me precision, you should ask me for what. But for this case, it's okay. I wanted to do that next, but anyhow. True positives by what did you tell me?
True positive plus false positive.
Plus false positive. Exactly. So when you write a precision immediately like this, you're basically doing it for y is equal to 1. For predicting y is equal to 1 class, this is the precision. I will come to an explanation of this a bit later in the second half of my discussion. But this is the formula. This formula you can fix. But whenever you use this formula, always remember you are doing it for y is equal to 1. Okay? Fine. Then what does this imply? What is the physical meaning of precision?
Percentage of predicted response values, those are correct.
That are actually right. So what is the proportion of positive class predictions that are actually correct. Okay, that is what precision means. What I'm going to do is I'm going to stop with these definitions. I'm going to ask you to go and look in which scenario precision plays a more important role, in which scenario recall plays a more important role. That is, that particular concept I'm going to leave it up to you guys to go and understand. All right, so that is going to be your homework for you. I'm just going to give you the physical meaning of precision, recall, and an easy method to remember the formulas. Okay, then what is recall? What is the formula for recall? And again, the physical meaning.
Percentage of response values captured by the model.
TP upon
TP plus FN.
TP plus FN. Exactly. So what is the physical meaning? Kalpita, you can go and tell me. Go on, tell me physical meaning of this.
The response values that were actually captured by the model, like if we say proportion of positive class predictions.
Pardon me?
The proportion of proportion of correctly predicted positive labels.
Correct. So that is basically of all the given positive classes, how many, what proportion, in fact, since we are writing it in ratio, let's do that. What proportion are correctly predicted? That is the definition for recall. So given that I had 5 people who had passed, how many am I correctly predicting to be passing? That is recall. Now look at these two interpretations, look at these physical meanings, go back and see. In a medical scenario, when you are doing drug testing, would you be interested in precision or recall? Right? So that could be an interesting thing to look at, more than accuracy, because whether I am correct is not important for me. Given a class, how good I am. That is what recall and precision tells you. So for a particular industry, particularly for medical field, what would be more important, precision or recall? Go look at it. I'm not going to give you the answer here, but that is something that you should explore and see the importance of precision and recall. Super. Now, given all of this, what is the accuracy for this particular scenario?
Can you scroll down a little bit? I would like to see the sentence for recall once again.
The recall. The recall is basically going to tell me of all the positive classes, of all the given positive class, which means the actual data is positive. Of all the given positive class, what proportion am I predicting correctly? 4 out of 5 I'm predicting correctly, which means 80%, right? So of all the positive classes, 80% is correctly predicted by me in my model. That is the interpretation of recall.
Okay. So if we really change the sentence, change the sentence and say proportion of positive classes correctly predicted, it is
proportion of positive classes correctly predicted is a column, no? Because here I have TP of all the given, because when I say positive, of all the given ones, because this is what is given to me. This I'm predicting.
Yeah.
Of all the predicted positive classes means it becomes the column. Whereas when I say of all the given positive classes, it becomes the row.
All the positive classes.
All right.
Okay.
So any other questions?
Sir, yes. Here recall is 80%.
Yeah, recall is 80%. 4 by 5.
And it is unlike precision that you told we should ask that for y equal to 1. So
no, it is the same thing. For both, it is the same thing. I'll come to this in a minute. For y is equal to 1, this is also recall for y is equal to 1.
Yeah, that I didn't understand it.
All right, I'll come to that. I'll come to that in a minute.
Okay.
It will all make sense in a minute. Okay.
Okay.
Because I'm not going to change the formula, I'm going to change something else. That is why I'm keeping the formula fixed and telling for the positive class. Okay. Now tell me, based on this particular table, I'll just zoom out a bit. Okay, based on this table, these formulas, what is the accuracy? Tell me the numbers. You can do the math later on also.
60%.
So 4 plus 2 divided by 10. That is going to be your accuracy. So that is 60%. Okay. What is precision?
4 by 7.
4 by 7.
So it's going to be 4 by 7. How much does that come out to be? Around 57%. Okay. 57, right? Yeah, 4 by 7, 57, correct. Okay, got it. Yeah. All right. Yeah, correct. 57. So what is recall going to be?
80%, 4 by 5.
50%.
It's going to be 4 by 5, which is going to be 80%. So these are the accuracy, precision, and recall for this particular table. Let me just do one small change here. Okay. Everyone with me so far? All of you got this? Any questions?
No, sir.
Wonderful. Then let's do one more thing. Let's just do one small change. I'm going to do this as, let's call this green column. And what I'm going to say now is, in the same problem, I'm going to say pass is equal to 0 and fail is equal to 1. That is going to be my scenario. If a person fails, that is going to be the positive class, and if he passes, that is going to be the negative class. Okay. So in the first scenario, we took p is equal to 1, p is equal to 0, p is equal to 1. F is equal to 0. Okay, let me do one thing. Let me draw the table again. That way it will be much more clear. In this particular scenario, what is happening? Okay. For this table, we developed it assuming pass is 1, fail is 0. Pass is 1 and fail is 0. Okay. Now we are going to create a new confusion table, a new confusion matrix. Green, but it's not freaking green. Okay. Let's do a different color. Let's do white. Okay. For the same problem, I'm still going to put actual has 1 and 0 and predicted has 1 and 0. That is not going to change. What I'm saying is, if a person fails, it is 1. If he passes, he is 0. And if a person fails, I'm going to predict him as 1. Else, if he passes, it is 0. This is the change. The true positive, true negative, false negative, and false positive, these remain the same. Okay.
Earlier you wrote pass is equal to 1.
Earlier I wrote pass is equal to 1. Now I am writing fail is equal to 1. My logistic
Divide.
regression is modeled assuming that my failed class becomes 1. Okay.
Okay.
I'll come to how it links in a minute. Okay.
So this time we will be predicting accuracy, precision, and recall for
For this table, we'll come to that table. Now tell me, what is the value for the first guy? When it is a pass, it is a pass. Is it a true positive, true negative, false positive, or false negative?
True negative.
True negative.
True negative. Okay. This guy is also a true negative. Third is also a true negative. This becomes a pass and a fail. What does that become?
False positive.
False
It
positive.
is a false positive. What is the third one? Pass and a pass. It is a true negative.
True negative.
So this is a, see, student number 6. Actual is fail. Prediction is pass. So it is a
False negative.
why? Can you tell me based on the logic I told you? Why is it false? Why is it negative?
Yes, sir. Because the false is because the actual and predicted values are different.
Okay.
And it is negative because it comes under p equals to 0.
Because my prediction is p is equal to 0. So it is a negative class. So false, negative. All right. Next one. 7. False,
Yes,
false,
negative.
false, it's a negative. So it is a false negative. Then what is this guy?
True positive.
True positive,
False negative.
false negative, final.
And true positive.
It's a true positive. All right. Okay, a shortcut. If it's a true positive, this is going to be a true negative. If it is a false negative, this is going to be a false positive. The negatives and positives will just basically change. That is the entire idea. So how many true positives do you have now in your data set?
2.
I have 2. This would be 4. I'll let you guys count. This would be 4. This is 3 and this is 1. All right. Everyone got this? If I count this particular table, I will have 2 positives, 4 true negatives, 3 false negatives, and 1 false positive. Yes?
Yes, sir.
Yes, sir.
Can you see what has happened between these 2 tables?
The entries along the diagonals have been
Along the
interchanged.
diagonals are now swapped. 4, 2, 1, 3. Is that significant? Now do one thing. Now compute accuracy. What is the accuracy for this particular guy?
60%.
Accuracy is going to be 4 plus 2 by 10, which is 60%. Super. What is precision?
2 upon 2 plus 1.
2 by
2
3.
by 2 plus 3. Oh, sorry. Precision. No, sorry.
2 plus 1.
2 by 2 plus 1, which is 3. How much is that? 2 by 3 is around 3, 6 or 18, right? Yeah. 66%. Yeah, around 66%. Okay. And what is recall? 2 by
2 5.
2 plus 3, that is 5. So 5 4s are 20, so 40%. So you see, my accuracy does not vary with what I use as my prediction class. It is same thing. But my precision and recall values are completely different. Because I'm using the same formula. That is why for y is equal to 1, y is equal to 1 is important. Whereas in this case, my y is equal to 1 is actually predicting this. For y is equal to 1 is basically predicting for y is equal to pass. For y is equal to pass. This precision is for y is equal to fail and for y is equal to fail. You do the same precision formula for this table, you will get these values for y is equal to fail. That is the importance of knowing what value you are actually predicting. If you are predicting whether a student will pass, appropriately a precision will tell you for that positive class. If you are doing for a student is going to fail, appropriately the precision will tell you for that positive class. Okay?
So when you write y is equal to 1, it means Here, y is equal to fail.
In this case, yes. In this case, in the violet case. Whereas in the pink case, it was y is equal to 1. That is why I originally said, say p is equal to pass. Pass is the positive class.
Yeah.
And did everything. That is why this is very, very important. What you are defining as your positive class is very, very important, because appropriately your precision and recall will change. All right. Everyone clear? And this is why in your practice problem, when we say what is the precision for the model, you should not blindly go and tell TP by TP plus FP. Unless and until I tell you whether you are predicting for the y is equal to 1 class or y is equal to 0 class. Appropriately, you should do the computations. Got it?
I have a
Yes,
question
sir.
here. Okay, but
Sir, hello,
what
sir.
exactly do we?
One person. Raise your hands. Let me call one person at a time. Okay. Yes, Ravi. Go ahead.
Yeah, it's. I mean, the entire thing goes upside down. That part is very clear. But how do I decide which event is a pass and which event is a fail in that case? Like
that when you build a model, it is not going to affect your modeling capabilities. No, it's only going to affect which value you are going to take as precision and recall. So you can use anything, whichever you want to do. As let's say I am a very strict person, I want to know who are going to fail. So then for me, my fail class will be a this thing will be a focus for me. Whereas no, I want to know how many people are going to pass my course. Is it difficult or not? Then I will look at the pass. That is all. It is more of a this thing, personal choice. Or personal choice, more of a business phenomenon. What is of focus to you?
So any practical scenario where precision is more important than recall,
That is what I told you. That is what I told you. You have to go and find out on your own. I specifically told this when I started off. You have to know where precision is important, where recall is important. And I gave you an example, business case, the medical scenario. In a medical scenario, what will be important? Go find out. But I'm not going to tell you because I wanted to do a bit digging. Then
yes,
you will get more
clarity. Okay.
Yeah. Okay.
can I
yes,
hazard a
Samarth.
guess? Maybe I'll be wrong. Can I hazard a guess on this case? In the medical scenario?
Not right now. Let other people also think. Maybe put it up in the discourse and we
Okay.
will discuss it over there. Okay.
Sure. Thank you.
Yeah. Yes, Samarth.
Hello, sir.
Yeah.
Sir, confusion in second confusion matrix. How do you fill
Okay.
up the data? First matrix is okay.
Second matrix is also the same thing. I just have to count these violent values that I've entered. Tn 1, 2, 3, and 4, right? So there are 4 true negatives. How many true positives? 1 and 2. So there are 2 true positives. How many false negatives? There will be 3. And how many false positives? There will be 1.
Then difference in first and second, what is the difference?
Diagonal elements are swapped now. This now becomes 4, 2, now it's 2 and 4. 1, 3, now becomes 3 and 1. Because of this, your accuracy, precision, and recall changes.
And
Making sense?
Again, I have to watch the recording. I thought. Sir, sir, second problem, sir. Hello.
Yeah.
Sir, when I open the portal and when I open the course calendar of BA and scroll down the previous week, after that, when I click on the recording or document which is already given in the previous week live session, then the window came that request access denied.
I don't follow. 1 second. I do not know what you mean. Let me just pull up the screen.
Actually,
So
suppose
you are
I want
going to May 2023. This is our course page. Okay. Where are you going here?
Then course calendar.
Course calendar. Monitor. Yeah. I do not have a course calendar.
Open course introduction.
Okay.
Then course calendar, general instruction. Then there is a calendar for this course.
Okay.
Okay. Then if I scroll down on the previous week.
Okay, you are going to the previous week. Yeah. Okay.
Yes, if I click on a previous week,
This one, 25th.
anything,
Okay.
and then at the bottom there is some yes.
This
If
one you
I
will not have access. Even I will not have access from my this thing, most probably.
why?
It's coming up. Yeah, it is coming for me.
Access denied. The window came.
Usually this is not give access because this is only for the account of MS 2002. Maybe I am added as an instructor, so I'll have access. But don't worry about this. If you want the recordings, all you have to do is go to the YouTube channel.
Okay, I access the YouTube channel but cannot find all the videos.
Yeah, so it should have been there. No, they have asked them to put everything up in the YouTube channel. They would have also done it.
I found that
No. Last week was quiz one, no? Quiz one discussion, right? Or no, last week was MLR. It should be there.
So there is a separate channel over there in business analytics. You can
Yeah, it is there.
it's not on the IIT Madras channel.
BS degree, then over the channel there is a business analytics.
Yeah.
But inside that did not found all the
No, you should have.
recordings. Don't know
You
why.
should have. This is the channel, for example. That would be the.
Up to July 1, it is there. It's
to
going right. Yeah,
It is there, right? Yeah, even MLR is there, no? Everything is there. Stream 6 days ago, stream
Yeah,
3 days ago. It is there, no?
a total of, I think, 5 videos are there.
Yeah, it could be 1 or 2 weeks. First week we didn't do, then 1 week we didn't do.
Maybe 1 week is not there, maybe.
Yeah, first week we didn't do. In between 1 we didn't do, and then 1 we didn't record. So that makes 8. The quiz discussion we said we will not be recording, so that discussion is not there. The first week we didn't have a live session, and then we started from week 2. We missed 1 live session in between because for the MLR we wanted it to be done together for 2 weeks, and then 1 lecture on quiz discussion that we skipped. That we didn't record.
Regression one, this is, I think, the next.
Yeah. Last week MLR's assumptions were discussed, and next one is the logistic regression.
Yes.
Yeah.
Sir, I have one question. I don't know if it's covered because I joined a little late. I just got to work.
Yeah.
In the lecture slides in logistic regression, sir was showing the log likelihood calculations in the Excel and all that. On top of it, he said, I've used the sum of log likelihood as the assumptions, and I kind of, there is B0, B1 to whatever, and I kind of optimized it to hit the. But where did those B0, B1, B2, B4 come from? I can share my screen if you want to.
No, you initially in Excel, what you usually do is you initially set some values, all right? You set some values, let's say B0 is 1, B2 is 3, B1 is something. Some values, you just put it randomly. Then you optimize it for the given data set. That is how SIR works. When you say that the log likelihood function, you want to minimize that function by changing these values, and it automatically calculates and gives you the best values.
For the lowest possible sum of log likelihood.
Yes.
Or the maximum.
Yeah, the minimum possible. No. How do you maximize log likelihood?
The negative of that. Correct. Yeah.
So you minimize it.
Okay,
So that is how it works. You can even start with blank cells. Not a problem. Blank cells means 0 values. That is all.
Correct.
That is an initial value from which it starts. Excel works like that.
Okay, got it.
Okay. Yeah, someone is in the. All right. Before I come to this particular thing, in practice assignment 7, they have not mentioned the class of interest and answer to that is cannot say. As a problem is not defined. Yes, exactly. Yeah. Okay. The previous one got.
No, sir, sorry, sir.
Yeah.
Maximizing the log probabilities, right? Maximizing the sum of log probabilities.
But I believe he has done negative value, correct?
No, that depends on the what you're getting is the
No,
odds,
you are going to
right?
maximize the log likelihood. Objectives. Okay, I have to see the video. What sir has done, then I can answer whether he has done a negative of that or whether he has directly taken that. I'll have to check that.
No,
but
he's taken the value as is. So either you maximize that or minimize the opposite of it. Either way.
Correct. What is the value that he has taken? I have to check. Log likelihood or negative log likelihood?
No.
The
log
cell
likelihood.
values.
No, log likelihood.
The log likelihood means it's a maximization problem.
Yeah, that's all.
That's a maximization problem.
Thank you.
Okay.
That's all.
Yeah.
Sir, I have a doubt in the derivation of that. May I ask now?
Derivation, no need. It's a bit out of scope for you guys. Let's not get into that. Okay. We are only focusing on the application orientation.
Okay, sir.
Yeah. We don't want to get into derivations.
Okay.
If you want to put it in the discourse, I'll answer it there, but not right now because I'm going to say something else, which is going to confuse people even further.
Okay, sir. Thank you.
No, don't want to do that. In fact, I'm going to give you a shortcut to all of this. That is what I meant. So, yes, Sunil.
So I have a question regarding primal and dual problems. So are we expecting any question around them as well?
You can ask. I will try to answer if I know. Because if you are going to ask specifically from a video, I will not be able to recall, but generally I can answer. From optimization.
So I have not got the idea how to find primal and dual. So I'm just asking for the basic idea, how to identify that and how to construct it.
Okay, what is the question?
So the question is like we have been given some certain equations, and based on that we need to find dual or primal equation.
Correct.
I'm not able to understand how to actually. I mean, if you have some video or link or something, I can
did you see the tutorial that was done by Srivatsa? Just look at the tutorial. That's a fantastic tutorial by Srivatsa. That should cover most of the things. But basically, this is what it is. Look, you have this thing objective, all right? Let's say in any linear program, you're going to have an objective, and you're going to have a constraints. This is basically the thing. So what will happen is, in a primal, you will have, let's say, x plus y, and let's say some 3x plus 4y, and you have an objective of maximizing this. And for these two x and y, you have constraints. Basically, a dual is going to convert the number of, how can I say? If you are constrained,
number of variables and number of constraints.
Yeah, number of constraints becomes the number of variables, and number of variables becomes the number of constraints. That is okay. But I'm just trying to give a scenario where that makes sense. Okay, let me do this. If you have a large number of variables, all right, let's say you have x1, x2, x3 up to, let's say, x10. And there are only two constraints for all of these variables put together. All right, x1 plus x2 something is less than or plus x10 is less than or equal to, let's say, 5, and x1 plus x2 plus so on and so forth plus x10 is less than or is greater than or equal to 0. Let's say these are the two constraints that you have. I'm just making it up. All right, then it would be easier to solve the problem if it had only two variables. Then what I will do is I will convert this to a dual. Now these two constraints will now correspond to two dual variables y1 and y2, and I will have 10 constraints. That is basically the entirety of going for a dual formulation from a primal to a dual, or dual to a primal. And there are certain links over here. I will not be able to explain the entire topic. If you want, I can do that, but I think that you should first see the videos, then come. Then I can pick up from some point.
Sure.
All right. Maybe I will do this. We have 2 weeks of DA. We have 2 weeks of conjoint. So 1 week I will do primal dual conversion problem. But that can be done only after your quiz 2, and quiz 2 has some primal dual in its syllabus that is covered in a week. So you'll have to manage, but I will definitely cover how to create a primal, how to create a dual in next week's lecture.
Okay.
Okay, but have a look at it before you do that. So that when I talk to you about, it's going to be something like logistic regression, right? Now I'm able to pick up from a certain point because you have already seen the basic videos. So I will do that. In next week video, next week's live session, we'll focus on conversion of problems from primal to duals and how it works. Okay, yeah. Okay, so
One question.
You said you were giving some shortcut. And
yes, I'm going to do that exactly. So when it comes to precision and recall, everyone always makes a mistake, and there is an easy way to remember precision and recall. That is why I use this particular table. No matter what comes out, I convert my table to this standard form. Okay, my standard form, like I said, is always going to have actual values on my horizontal rows and predicted values on my vertical columns, and it's always going to be 1 0 1 0. This is the standard format, and in the standard format this is always the case. Even if you are not able to remember this one cell. Based on this one cell, everything else can be populated. When I have 1 1, it is true positive, so the diagonal value to that is going to be a true negative. The only change is going to be negative. All right, then the value that is parallel to this is going to be change true, keep true as it is. Sorry, change true to false, change positive to negative. That is going to be this value, and this diagonal element is going to be, this is true, so this is false, this is negative, so this is positive. So this is the most easiest brute force method to fill in what is true positive, which cell is true positive, which cell is true negative, which cell is false positive, which cell is false negative. You can use this approach, or you can use this approach that I told you. Both work. All right. So for all those who find that difficult, use this. If you find this difficult, use that. Anyhow. So once you have done this, your confusion matrix is ready. Okay. Next comes the question of how do I tell precision formula and how do I remember recall formula? All right. Again, it all comes down to true positive. So in both precision and recall, the numerator is always going to be TP. There is no change there. Recall starts with an R. So it means row. What is the row for true positive? It is true positive plus false negative. So that is going to be in your denominator. TP plus FN. So recall, it starts with an R, so it refers to row. So true positive plus false negative. So precision, it starts with a P. It is not an R, so it's going to refer to the column. So it's going to be true positive plus false positive. That is all. So this is the most easiest method by which you can remember precision and recall. No matter how someone gives you the table, you can always convert it into a standard format and then solve your problem for precision, recall, accuracy, everything. All right. So this is the shortcut that I wanted you guys to remember. You don't even have to mark up the formulas. Just remember recall row. So row is TP by TP plus FN. That is all. All right. So this is the shortcut.
So can you repeat how to update the TP and the FN?
How to update the TP? All right.
The first part.
Let's do it again. So I am going to say my structure is remaining same 1 0 1 0 actual predicted. I will fill up this top left hand side corner as TP. That is always fixed. From there, I will move to the diagonal element. This is going to be a true. The true remains the same. Instead of positive, I'm going to put negative. So the opposite of that. Then I'm going to move parallel to TP. This cell is going to be, if it's a true, it's a false. If it's a positive, it's a negative. Then I'm going to move to the diagonal element, true, negative. From here, I'm going to move parallel to it. So if it's a true, it's a false. If it's a negative, it's a positive. That is all. Okay. This particular method will also hold true if the numbers are changed. So look at that on your own. But this is the most easiest thing. All right. And if you are using this method, always remember this is where the importance comes. What you are going to define as y is equal to 1, what you are going to define as y is equal to 0. Based on that only, you are going to have your precision and recall formulas, because I'm not changing the formula. I'm changing only the table number values. This is for now. The precision is for y is equal to 1, and for y is equal to 1. Recall is also y is equal to 1. What will it be if it is for y is equal to 0? What is the precision and recall for y is equal to 0? Then what are the true positives?
True negative. Just do the calculation on the other diagonal.
Yeah, this is true positive. This becomes a true negative. So since this is a true positive, this becomes a false negative, and this becomes a false positive. Now you use the same formula, taking these values, and it will work. Okay, that is how you do it.
So when we flip them, we just 0, 1, 1, 0. We just change the position of these things across the diagonal. That's all, is it?
Across the diagonal, and appropriately take the numbers. So if I want to use it for the same thing, if I write it in the same black ink, what I will write is precision for 0 is going to be true negative by true negative plus false negatives. Recall for 0 would be true negative by true negative plus false positives.
So the T's and F's remain the same, only the N's and P's get flipped.
Yeah. You can remember it however you want. It is just this thing.
Okay.
It is just a mechanism.
So what do we so we basically normally we consider it as y is equal to 1, but if we say y is equal to 0 specifically, that is when we actually.
That is when you get into trouble.
Okay.
This is something that every year, somewhere in your this thing, I'll ask a question, everyone falls prey to it. That is why I'm telling it during a live session.
Sir, if that's the question which is asked, we first construct this and then flip it, is it? Or
exactly.
Or if I just consider.
You can consider, look, what if I ask you precision for y is equal to 1 and recall for y is equal to 0? My question is, I'm asking you precision, accuracy, precision and recall. I'm telling accuracy for the model, precision for y is equal to 1, recall for y is equal to 0. Then how will you do? You will basically have to construct the table and you should be very clear on what it is. If you are having that clarity, then well and good. If not, then appropriately find the shortcut method to do it.
Thank you. This is a tricky one.
Yeah, this is a tricky one. That is why I was explaining it for the last.
So accuracy remains.
Accuracy always remains the same.
Okay. So in both the cases, the confusion matrix remains the same.
Yes, you can keep it. A confusion matrix does not remain the same, no? When I'm predicting for y is equal to 1, the diagonal elements are changing.
So when you are asking for y is equal to 1 and then you are asking for y equal to 0.
You can either take it from the same confusion matrix. Yeah. If you are smart enough, you can do it like this. If not, if you are getting confused, then again construct a new table, new confusion matrix for considering y is equal to 0 as the positive class and use this formula. Not a problem.
So when you are writing y equal to 0, it means y equal to 0 is a positive class.
What I'm telling you is, if I ask precision for y is equal to 0, from this confusion matrix table, the formula changes.
No, formula I am not bothered about.
Ah.
First I'm aiming at that if I could be able to construct the confusion matrix, the standard matrix
Okay.
that you have shown
Okay.
here.
Okay.
So my approach is like first to understand from any table and write clearly the confusion matrix in the standard format, and then
you
apply these formulas.
Apply these formulas. When you apply the formula, define which is your positive class. Then take the TP, TN, FP, and FN.
Whatever it is, once the standard this table has been drawn, then the positive and negative class.
The values are not filled. Be very clear on that. The table is drawn. The values are not filled. You have to again recompute the values, no?
Yes, sir. We'll compute the values from.
Yeah, then directly apply the formula. No issues.
So I can I suggest
just a minute.
Yeah, go ahead, Kishle. Go ahead.
Sir, my confusion is that for any data table, what you have shown there, if we write this confusion matrix in the standard format, then my formula doesn't change, no?
No, your formula depends on what is your positive class. Which class you are finding the precision for, which class you are finding the recall for. This particular table that I drew.
Yes,
okay, let me just draw the table. This particular table that I am drawing.
This matrix, yes.
Yeah, TP, TN, FN, and FP.
Yes.
Assuming 1,
and
0,
1, 0.
1, 0.
Yes.
Actual predicted. This is fixed.
Yes,
okay?
That's fixed.
This is fixed.
1 is my positive class and 0 is my
1
negative.
is your positive class, 0 is your negative class.
That's fixed.
For your actual data, is 1 representing pass or fail varies now. Based on whether it is pass or fail, the number of true positives and true negatives change, right?
That's what he's saying, sir. Sir, if you come to that table you've come, I think I got. So no, sir, the one you just drew now, the empty one. Yeah? So if you can you just change that 1 to positive and 0 to negative? Just give me 1 minute, sir. If you can just do that, I'll.
No, you want me to change 1 to positive.
Positive.
Okay, let me do that 1 second. You are asking me to change 1 to positive and 0 to negative. Okay.
Same.
Positive and negative. Okay.
Now, depending on how we define the problem, whether we are interested in fail or pass or whatever, right? So let's say we are interested in fail, that becomes positive for us.
That becomes a positive class.
Yes. That's what I'm saying.
That's what I got it, Kishle. That's what.
Yes. I will mark fail over there. Yes.
And then your formula holds true. Yes.
Yes. Then my formula will hold true. Yes. And I just need to configure in my mind that what is my f is equal to 1 or f p is equal to 1. That's
correct.
That is all.
The only problem which sir was highlighting is if in the same question they ask you precision for y is equal to 0 and then recall for y is equal to 1, then we have to draw 2 tables. Just to be sure.
That's sure. That already sir has done.
Yes. That is what I'm trying to drive. Yes.
Despite all this, I have a feeling I'll make a mistake in the exam because it's very confusing.
Yes.
Is that the reason why it is named so?
Confusion matrix. I do not know. I do not name it, but whoever named it was in Tamil we call it Dirghadarsini. I do not know.
Definitely, he would also have been confused.
Yeah, it's spot on.
Yeah. So name the thing lives up to.
First time when I listened this, I thought that I have incorrectly listened this name. How can a table be named confusion matrix?
Yeah. Okay. So this is what I had for today, and this is the important thing in logistic regression. The others you will be able to just see and get it, the odds and all of those stuff. So guys, find it out from there and look at the importance of precision and recall. It's a very, very important thing. There are other terms also. You have something called specificity and what is it? Specificity and one more. That is also there.
Sensitivity.
Sensitivity, yeah. Sensitivity and specificity. Those are other 2 terms. One will coincide with recall. The other one is that. So just all of these terms are just floating around in your logistic regression domain or any classification domain. But we are focused only on precision, recall, and accuracy. So have a clarity on that. Okay, so this is what I had. Any other doubts, or else it would be nice if we can wind up. Since I have another thing. Yeah.
What is deviation?
Deviation in what sense? Deviation basically means movement from my actual value. So, in what sense are you asking the term deviation?
It is a metric, sir.
Deviation is just movement from my actual value. There's no specific metric per se that I can recall of. Sorry, I can. I'm not used to recall. I can remember. Did you see it somewhere? I do not know where. Deviation is basically why. Basically, an error is a deviation. No, that is all. I do not.
I saw in the lecture, sir. That's why I asked.
Saw in the lecture deviation. Okay, then I have to get the context. Yes, Kalpita. Do you know which context?
No, sir, but I have doubts.
Okay, yeah, go ahead.
Sir, I wanted to ask about the threshold that we were discussing in tutorial. Is there a particular way to change that threshold in Python?
Yes, you can. In logistic regression, the code will give you an option not to set threshold. Just look at the documentation. One of the third variable or fourth variable in that is threshold. You can change it. Obviously, because you need to have control over the threshold to predict whether something is predicted as pass or fail. No?
Yeah, correct.
So yes, so you will have control. It is possible. The code documentation should have it. It is definitely there. It is definitely there. Yeah. Just look at, let's say you are doing logistic regression. I think, what is the command for it? Logistic regression. I forgot the command. In that command, once you open the box and specify what is your actual, what is your x values, what is your y values, after that you can specify the threshold.
In the classification report?
No, not in the class, in the model itself. The classification report depends on your threshold. Default is 0.5. The model, when you are building the model itself, when you specify what is your x, what is your y, at that point itself you can specify the threshold.
Okay, in fit.
In fit.
Okay, got it.
Yeah.
One more doubt regarding the ANOVA table. I think Ravi sir also had asked in the previous session. There is SS of regression model. We say it is sum of
squares of regression. Yes.
What value is it actually?
What value? Sum of squares of
like
regressors.
Of residue, we can say it is sum of squares of error.
Okay. The sum of squares of correct. How can I tell this?
One is error, the other one is
regression. Regressors.
If you took the prediction to the average and calculate the differences, that plus this is the total sum of squares.
No, that is okay. She's asking what is the physical meaning of, let's say for error, you are computing as the difference and then adding all of that. That is error. She's asking the physical meaning of regressors. How can I tell it? The formula is what he said.
On discourse?
Yeah, do post it on discourse.
I'll sir, see for every x, see what are we predicting? We are predicting y given x, right? That's what we are looking for, probability of y given x for each x, right? For each x, the y is not a point estimate, it's a distribution.
It's a distribution.
Yeah, there is a mean.
Correct.
The distance to the mean, basically the deviation on each of the prediction is what those sum of squares are.
From the mean value of the from the distribution of y.
Correct.
Do you understand what he's telling, Kalpita?
Yes, sir.
You have understood then very good. So that is what it is. I just wanted to say in a different sense, but yeah, that is what it is. You are predicting a value. How far is that predicted value from the distribution of the predicted value? That is your sum of squares for regressors.
If you assume mean is it's unbiased estimator, then how far away are you from the unbiased?
From the mean, UMDOE.
Okay,
I don't know whether you understood it, but
Vasu, just correct me if I'm wrong. Is that also a measure of how far it is from? When you say standard deviations is a measure of how far or how much data is fitting within the curve. Does it also come similar, or am I mistaken?
It will not come similar. Now, standard deviation is for that distribution. This is in the distribution. Let's say you expect the mean value to be around 10,
Right.
and you are getting, let's say, 8. Then
Right.
the 2 is that sum of square of residuals. Right?
Yeah.
10 minus 2. That is sum of square of residuals. That 10 is the mean, and that distribution will have a standard deviation. That deviation is basically got by all of these predicted values sitting across it. You have 1, 8, you could have had one that is 9, you could have one that is of 11, 12, so on and so forth. No, that is that standard deviation.
So basically, for the predicted value, on an average, how far away are you from the expected value?
From the expected value, yeah.
Because each point is a distribution in itself. It's not. It's like given a xi, you're predicting the y, right?
Correct.
So that y is a random variable. It's not a fixed point estimate, right? So then you're just saying that on an average, how far am I from the mean, right? That is basically the regression sum of squares. That's what your regression is telling you. Versus the errors, which is actual. What is the actual? Mean is the expected.
Yeah, you actually found that value. It could have had any other value in the distribution. So that value that you actually got and what you are predicting, that is the error. And in that distribution between the mean and your actual value, that is why you use the mean as the unbiased estimate. The uniformly minimum variance unbiased estimate is your mean. So from that mean, how far you are. But yeah, this is all getting too technical. We are not focused on that in BA. But yeah, you should have asked this question during your maybe your MLT. Yeah.
Correct. Except that there we didn't look at it as a sum of square from a regression, like the regression output perspective. We had a slightly different perspective. Here, it's actually making a lot of sense when we are looking at it in terms of real data.
Okay. Okay. Yes, good one. I believe that is why sir would have used deviation.
Deviance, sir.
Deviance. Okay, yeah. I believe that is where sir would have used the term deviance.
Yes, sir.
Okay, so this is the deviance, between sum of squares of regressors. That is why you have the deviance.
Okay, sir. And there are two more terms.
Before we start again, Kalpita, are your doubts over?
Yeah, yes, sir. I got the idea. I will also post it on discourse. Thank you.
But I do not know how much better to explain it. Okay. Anyway, I'll think about it. Yeah. Yes, Gufran. Gufran.
Yes, sir. Yes. AKK and base information criteria.
BIC and AKK information criteria, AIC information criteria. A bit far-fetched, man, these two. Let's not get into it. Because AKK information criteria is basically and BIC both are going to basically tell you whether I should add this additional X or not. Yeah, X or not into my model.
Okay, sir.
Let's not get into it.
Okay.
Yeah, let's not get into it.
Okay, fine.
It's there in MLT. Okay, just to mention the mention of them, AIC and BIC, both. Even there, I do not think they will get into the computations of AIC or BIC or what they mean, more than the fact that they will be taken for, their values will be taken for determining whether an X should be included in your model or not. I don't believe anywhere in any course at this level, at least, they will look for beyond that. Only if you go into a pure stats course where you are going to understand in depth about all of these, you will get you will require more knowledge of AIC.
Okay, fine.
All right. Anything else?
No, sir.
Hello, sir.
Yeah.
Yeah. So in the
Thanks, everyone.
assignment 3, we have to only go through the instructions given in the before the questions, right? That is enough.
Follow the instructions to the letter. If they have asked you to build it in Python, build it in Python. And if they have asked you to do it in Colab, do it in Colab. Do not use any other thing. All right, any other versions of Python or any other softwares of Python.
Okay, it is mentioned in logistic regression, so we should just use logistic regression. We need not give any parameters in it.
You don't have to give any parameters. Unless and until it's specified. I do not know. It would be better if you post this in Discourse and tag Ram. Swami will be able to answer it because he created the assignment. He'll have more control. Okay, just post it in Discourse and ask him. He will answer.
Okay, thank you.
Okay.
I have one last question. For the quiz, it is from week 3 to 8, is it?
3 to 8, yes.
Okay. And will we be having? Okay, the mock has already been released. Okay, fine.
The mock has been released today.
Will
On
we
your
be-
specific lesson, so everyone can thank you since you insisted it last time. I created it today morning.
Thank you.
Okay.
And will we be discussing the mock by any chance before the quiz, or?
No, man.
Okay.
Mock is fairly straightforward. So.
Okay.
And this quiz is also given the performance in the quiz one. This quiz is comparatively easier.
Okay. Okay, we'll discuss about it after the quiz.
Okay, fine.
Yeah, just one question. Like, what are the weeks covered for this Q?
3 to 8.
3 to 8.
Week 3 to week 8.
Okay.
All right. Thank you very much. Thank you. Good night.
Thank you. Good night.
Yeah, thanks everyone.
Thank you, sir.